So once again, I will explain the concept for those who joined late. Congruent figures means two geometric figures which have the same shape and size are known as congruent figures. So look at these two circles which have the same shape. Shape is circle and size is also same. And two triangles also like this. Next, similar figures. Right, similar figures. Similar figures means shape will be the same, which means circles, both will be circles, but size will be different. Okay, I repeat, shape will be same, but size will be different. That means geometry figures which have the same shape but different size are known as similar figures. Please write the definition. Geometry figures which have the same shape but different size are known as similar figures. So geometric figures which are the same shape but different size are known as similar figures. Examples. If you draw two line segments, we can see they are similar. So this is a line segment. I'm going to draw one more line segment. Look at these two. The shapes are the same. Shapes means line segment is a shape, but size are different. So these are similar figures. Other two examples like rectangles. Okay, so look at two rectangles. This is a rectangle. And I'm going to draw one more rectangle with a different size. Okay, so these two are of the same shape. Shape is rectangles, but size are different. So this is another example for similar figures. Geometry is visualization. So you have to understand the concept well by visualizing the things. So next I am going to draw triangle. Okay, triangle means if you draw equilateral triangle, both should be equilateral. Otherwise, the shape won't be same. So I was trying to draw equilateral triangles like this. Equilateral triangles are similar. That means their angle should be same. Otherwise, the shape you won't get similar. If you draw one of them is right triangle and another one equilateral, their shapes are not the same. Okay, if you draw a right triangle, both should be right triangle. That is the reason triangle should be same for triangles. Here, the shapes are the same, but size are different. So this is the point. Having the same shape, but different size. These types of figures are called as similar figures. Okay, one more example, like circles. Okay, am I audible? Can you hear me?
Yes.
Yes,
Okay,
sir.
Yes, sir.
Hanley could not hear me properly. Hanley, shapes are the same. Shapes are the same, but size are different. In all these figures, in similar figures, I was doing like this. First, I was drawing the line segment. Look at these two. Shapes are same, but size are different. If they are congruent, size is also same. Second, I was drawing rectangle. Shapes are the same, but size are different. Now in these two, okay, circles, shapes are the same, but size are the different. Okay, so these types of figures are called the similar figures. So both the basic point is clear. Congruent figures and similar figures, right, children? Is there any doubt?
So,
Okay. Please ask.
uh, in the triangles basis, they both are triangles, right? So same shape.
Same shape. Shape means I was trying to draw equilateral triangle. But if I make one of them like right triangle and another one equilateral, both are triangle, but their shapes are not the same there. Okay,
Okay.
fine. But here the shapes are the same. When we draw two equilateral triangle, their shapes are the same, but sizes are different. Another doubt is acute and isosceles triangle are not similar figures. No, they are not similar figures. Isosceles triangle and another isosceles triangle. Two isosceles triangles we have to take. That means this is a point for triangles. Angle should be same. Then only you will get the shapes similar. Shapes same. Okay. But sides can be different. Now we are going to study detail about sides. Different means there should be a proportionality for the sides. So now we are moving in detail to these types of things. Similar triangles. So our chapter is mainly dealing with the triangles. Other shapes we are not going to study in detail in this chapter, only triangles. Even isosceles triangles also, if we take two isosceles triangles, we may not get they are similar. But equilateral triangles are always similar because all the angles are 60 degree each. Okay, so now write the subheading similar triangles. Subheading similar triangles.
So we
Okay,
should draw the figures, sir.
yes, the last few figures you can draw. The line segment and the rectangle, rough figures are enough. Then two triangles. Okay, so these types of few figures you can draw to get the clear idea about similar figures. Did you complete this one? The similar figures and the diagrams? Okay, so now we are moving to similar triangles. Shall I start similar triangles? Okay. So two points are there for similar triangle, two triangles to be similar. Point number one is their angle should be the same. Angles should be the same. Point number two, their corresponding sides should be proportional. Proportional means they are in the same ratio. That is called a proportional, okay? Or are in the same ratio. Corresponding sides are in the same ratio. So please write. Two triangles are similar. Two triangles are similar if point number one, their corresponding angles are equal. Their corresponding angles are equal. Point number two, their corresponding sides are in the same ratio or proportional. Their corresponding sides are proportional. Their corresponding sides are proportional. Okay, so these are the 2 points. Two triangles are similar if their corresponding angles are equal. Point number two, their corresponding sides are proportional. Their corresponding sides are proportional. So if you write this in detail, oh,
Sir, if we say the corresponding sides are proportional, can we say it's congruent?
no. For congruency, corresponding sides should be equal.
Sir, only if the corresponding sides are equal, then they are called congruent.
Yes. If the corresponding sides are equal, then the two triangles are congruent.
Okay, sir.
Did you get the meaning of proportional and congruent? Proportional means they are in the same ratio only, not necessary to be equal. So I will write that in detail now. If triangle ABC is similar to triangle PQR, we write like this. We write triangle ABC. So do you remember in congruency we were using equal to and this type of symbol. So for similarity, equal to is not there because shapes, size are not equal, only this one. So how to read this symbol, is similar to. So this means triangle ABC is similar to triangle PQR. I'll explain that once again. So this sign is for is congruent to. This is for is congruent to. Okay, is it clear? This we have studied already, but if only this one, it is similar to. This is for is similar to. The first one is for is congruent to. So that equal to part is not there. Equal to sign is not there. The sign on top of equal to you can see. That one is alone for is similar to. Okay, so how to read this? Triangle ABC is similar to triangle PQR. Now you see, how can I write these 2 points in the terms of the sides and angles? If triangle ABC is similar to triangle PQR, then we can write their corresponding angles are equal. Corresponding angles are equal means AB, it should be equal to PQ. AB means the first and second I am taking. AB, the first and second on the second part is PQ. Then BC should be equal to which one? Can you tell me? BC equal to
QR.
UR. Correct. It is similar. Sorry, it is. I am writing.
So it should be in
Sir, this is for congruence, sir.
I was writing the congruency. Instead, I will write the angles equal. So first of all, angle A is equal to angle B, the first angle. Next, angle B, it should be equal to angle Q, and angle C is equal to angle R. This is the first point. Their corresponding angles are equal. Point number 2 is their corresponding sides are proportional. Equality is for congruency. Here it is proportionality. Proportionality means they are in the same ratio. That means AB by PQ. That is called a proportion. AB by PQ equal to BC by QR is equal to AC by PR. So this is there in similarity. Their corresponding, second point please note down, their corresponding sides are proportional. So is it clear? All of you understood that one? The second part? First part is their corresponding angles are equal. Corresponding means when you write the name like A, B, C and P, Q, R, the positions are very important. Positions are like this is the first, second, third, and here first, second, third. That positions we keep. First position angle A, and on the right side first position it is angle P. Angle A and angle P are equal. Second position it is angle B, that should be equal to angle Q, and third position it is angle C, it is equal to angle R. Same way we can write the proportionality of sides. AB by PQ is equal to BC by QR is equal to AC by PR. So all of you understood this point? I hope this point is clear to all of you. Is it clear, children?
Yes, sir.
Two triangles are similar means point number 1, their corresponding angles are equal. Point number 2, their corresponding sides are proportional. Then triangle ABC is similar to triangle PQR means we can write using this symbol. Triangle ABC is similar to triangle PQR. So this sign is for E similar to. On the other way around, if it was congruency equal to also was there, then triangle ABC is similar to triangle PQR means their corresponding angles are equal, which means angle A equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. Similarly, we can write AB by PQ is equal to BC by QR is equal to AC by PR. Okay. So I hope all of you understood this concept. So now you can see the textbook exercise 1.6.1. Please take exercise 6.1. The first question answer it is to write there in the textbook itself. It's like one word answer. Okay, 6.1 all of you took. Question number 1, you can put the answer in the chat box. All circles are dash, congruent or similar. All circles are congruent or similar. Okay, so I'm getting the answers. All circles are similar. Okay, except one, everyone sent the correct answer, similar. Because circles means different size will be there. Okay, but shapes are same. So all circles are similar. Similar is the answer. So please note down the answer in the textbook itself. Or you can write there in the notebook, doesn't matter. All circles are similar. Next, all squares are. All squares are. Please put the answer in the chat box. Similar. Your answer is correct. Similar. Because squares also different sizes will be there. Okay. So similar is answer. Next. All dash triangles are similar. Isosceles, equilateral. put the answer in the chat box. Nitya send the correct answer, and then Gogul, Anushka, Muhammad Saif, all correct answers. Raga, correct answer. Vinu, Rebecca, all sending correct answer. Manav, correct answer. Okay, so all dashed triangles are similar, isosceles or equilateral. Ian, correct answer. What about others? Equilateral is answer. Equilateral is a correct answer. Ida also correct answer.
Sir,
Equilateral.
even I sent, sir.
Sorry?
Sir, even I sent.
Okay. Majority of you have sent. Okay, yes. Next, two polygons of the same number of sides are similar if their corresponding angles are dash.
Equal.
Their corresponding sides are dash. Corresponding angles are
Proportional.
equal. Angles are equal, right? And the sides are proportional. Okay, this one also correctly have sent. Fine. Corresponding side angles are equal. First part is equal, and corresponding sides are proportional. Second part is proportional. Give two different pairs of similar figures, non-similar figures. Similar figures already have given in the above slide. You can see similar figures. A lot of examples are there. Like this, non-similar figures. Like this, if you draw.
Isosceles and
Isosceles triangle.
Oh, okay, fine. Two triangles of different shapes. Like right triangle and isosceles triangle you can draw. Or two isosceles triangles, doesn't matter. Now, state whether the following quadrilaterals are similar or not. No. Can you tell me the reason?
No, sir.
Sir, one is a
So the corresponding angles are not equal.
That is the point. Corresponding angles are different. So please write the answer over there. Question number 3, answer is no. The reason, corresponding angles are different. Corresponding angles are different. They are not equal. Okay. Corresponding angle should be equal for any type of polygon, whether it is triangle or anything. Yes. So now we are moving to the first theorem of this chapter, that is basic proportionality theorem or Thales theorem. You can see the picture of Thales there in the next page, in page number 123. Thales lived in BC 640 to 546 BC. Okay, and it is believed that he had used this result, basic proportionality theorem, on similarity of triangle. A famous Greek mathematician, Thales, gave an important truth relating to equiangular triangle. Equiangular means they are similar triangles. Okay, so that is under his name, Thales theorem or basic proportionality theorem, BPT, basic proportionality theorem. Its proof is a 4-mark question in the examination. Very important. So in this chapter, out of 4 theorems, before 4 theorems were there, 2 theorems proof are deleted, statement is there. So this type of the remaining proofs are for 2 theorems now. So they may come there in the examination. Okay, very important now. So please write. We are going to study that 4-mark question today itself.
Oh,
Basic.
I have a doubt.
Yes, please ask.
So why can't isosceles triangles be similar?
Isosceles triangle angles may not be the same. That's the reason. Angles may not be the same. For example, isosceles triangle means only base angles are equal. That is the condition for isosceles triangle, right? These two sides are equal and base angles are equal. If I draw 2 isosceles triangle like this. Okay, so look at these two. So in these 2 isosceles triangles, for example, these 2 angles are 30 degree. And these two, it may be 60 and 60, like that it will happen. That means angles may not be the same. Because of that, shapes may not be the same. Is it clear?
Yes, sir. Thank you, sir.
But isosceles triangle, equilateral triangle, always it will be similar. Now the next Heading is the Theorem 1, Basic Proportionality Theorem. Right, Theorem 1. Theorem 1, Basic Proportionality Theorem. Basic Proportionality Theorem. In bracket, short form is BPT. BPT. Or this theorem is also known under the famous Greek mathematician's name, Thales theorem. Thales, Thales theorem. Thales theorem. So please write the heading, Basic Proportionality Theorem or Thales theorem. The 4-mark question, it will be with the statement, it may be asked, or state and prove.
Which chapter?
Thales theorem. This is chapter number 6, triangles. Chapter number 6, I think you joined late, right? Chapter number 6, triangles.
Sure.
We started with geometry chapters. Okay, chapter number 6, triangles. May please request me to get that record. I'm recording the class. Okay, so I will send you that so that you will get the initial part of this class. Okay. So please write. The question it will be like this: state and prove basic proportionality theorem. This is a form of question. State and prove basic proportionality theorem, BPT. And it is a 4-mark question. State and prove BPT, basic proportionality theorem. That question is a 4-mark question. Okay, so first of all, I am going to write the statement and then proof. In the proof part, we have diagram. First, we have the diagram and then given to prove construction. It is same as last year's geometry proofs. So please write the statement first. Statement. This is the theorem statement. If a line is drawn, if a line is drawn parallel to one side of a triangle to intersect the other two sides. To intersect the other two sides in distinct points. Comma, the other two sides are divided in the in the same ratio. Okay, so please write the statement. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points. comma, the other two sides are divided in the same ratio. I will explain the statement with a diagram and then given to prove construction. These are all required for proving this theorem. So the first part of the statement is given part. A line is drawn parallel to one side of a triangle. Okay, so that is for the given part. So for the proof, we start with a diagram. So we'll draw a triangle. So you can draw a triangle. Okay, so please draw a triangle and name the triangle ABC. ABC, these are all part of given. Then a line is drawn parallel to, if a line is drawn as parallel to one side of a triangle to intersect the other side in distinct point. That means, so like this, a line is drawn. Okay, so for example, this is the line DE. I'm going to name this line DE. So this DE is drawn parallel to one side. That means this DE is parallel to BC. It is a part of given, right? This arrow means these are parallel. D is parallel to BC. Line is drawn parallel to one side of a triangle to intersect the other two sides. Other two sides are like AB and AC in distinct points. Say the distinct point, two different points are D and D. Then the next part is the part which we need to prove. Then the other two sides are divided in the same ratio. That means the other two sides means AD by DB. We want to prove this one. AD by DB equal to AE by EC. Some constructions will be there on this one. But before writing construction, I will write given and to prove. So please write given. So please complete this diagram. All of you please draw this diagram. Diagram is very important part of the proofs. You will draw triangle ABC, then D, it is drawn parallel to BC. Okay, so please write given a triangle ABC in which D is parallel to BC. D is parallel to BC. Then the next given part is D intersects AB and AC.
So those figures will be given or we have to draw?
Figures we have to draw.
Okay.
Even statement also may not be given. Okay, in some examination, with the statement they will ask. Okay, or it will be like this, state and prove BPT. We have to write the statement, draw the figure, and then given to prove everything. Okay.
Yeah,
So
okay.
this one you must study perfectly. It is very important for marker. A triangle ABC in which D is parallel to BC, that is given. Then D intersects AB and AC at D and E respectively. At D and E respectively. Okay, children, these are the given facts. A triangle ABC in which D is parallel to BC, and second given part is D intersects AB and AC at D and E respectively. Then to prove, okay, so this is the point which we need to prove here. So we want to prove the other two sides are divided in the same ratio. That means we need to prove AD by DB is equal to AE by EC. AE by EC. So this is a mathematical form of writing. The other two sides are divided in the same ratio. Other two sides means AB and AC divided in the same ratio means AD by DB, that should be equal to AE by EC. We have some very important constructions here. Construction number 1 is, did you complete till here, all of you?
Yes, sir.
Okay, so please complete till this part. Okay, so these are the constructions part. The first construction is, you will join this like this. Join B and DC. So we'll join this one, B like this, and CD, this one. Okay, so we'll join this in your diagram, and you will write here, join B and CD. Join B and CD. One more construction is there. So that construction is like this. Draw DM perpendicular to AC like this. DM. Draw DM perpendicular to AC. So from here you will draw this one, DM, which makes angle 90 degree. DM perpendicular to AC. And one more thing, EN perpendicular to AB. EN, which will be perpendicular to AB. So the second construction is EN which is perpendicular to AB. So these are the two 90 degree. That means we are trying to draw heights to the other sides. Okay, so DM perpendicular to AC, and you will write here, draw DM perpendicular to AC and EN perpendicular to AB. Draw DM perpendicular to AC and EN perpendicular to AB. Okay, children, so these are the constructions here. So we have now completed the preliminary part of the proof. See the preliminary part, statement, and then the diagram given. Given means a triangle ABC in which D is parallel to BC. D intersects AB and AC at D and E respectively. Then we need to prove AD by DB. AD by DB is equal to AE by EC. Construction, join B and CD. Then draw DM perpendicular to AC and EN perpendicular to AB. Okay, so this is the part. Now we are going to start the main part of the proof. Okay. For the proof, we will be taking area of triangle concept. Area of triangle, you know, half into base into height. So that concept we will use to prove this, the remaining part. First of all, we'll take this one, triangle ADE, the topmost part, triangle ADE. Okay, and then we will take the triangle DBE. That means on the left side, two triangles we are going to take. The triangle number one is ADE, and then triangle DBE. On the other side, we will take AED and ECD. Okay, so like this, four triangles we are going to take, and we will use their proportionality. Okay, because we want to get AD by DB. So you can remember like this. First of all, we have to take the triangle with these two as the bases, AD and DB as the bases. So the triangle is ADE with AD as the base. So see the proof. So I'm going to take the triangle with AD as the base, that is ADE. Area of triangle ADE is equal to AR means area of triangle ADE. We will use the formula half into base into height. So here the base is AD and the height is EN. That is what we are drawing the perpendicular one. Half into AD into EN. So I took area of triangle ADE because I wanted to get AD as the base. Is it clear? All of you understood ADE? The triangle AD you can see there in the diagram. You will see AD is the base. So look at this. This is the base. AD is the base. And this EN is the height. Okay. So half into AD into EN. Next, I am going to take the triangle with the DB as the base. The triangle name is DBE. You can see the triangle DBE. So area of triangle DBE is equal to half into base into height. Here the base is DB and the height is same, it is EN. Because when you take DBE, look at the triangle DBE. So this is the one, the triangle DBE. So this is a triangle DBE. So in this triangle, the base is DB, but the height is EN. It is an obtuse triangle, so the height is outside the triangle, and it is EN. EN is the height. I hope that is clear. In small classes, you have studied how to consider the base of the obtuse triangle. So EN is the height, height of the obtuse triangle. Okay, so now we will divide these two. In between, I will scroll a little bit up. Hanley did not complete some part. Hanley, is it enough? Okay. Or I will send you the record, okay, if any part is pending. So now all of you please write these two. Area of triangle AD is equal to half into AD into EN and half into a DB. I took DB into EN. So here we are taking two triangles with the AD and DB as the base. Now we will divide these two. Okay, so when we divide these two, what will be? How is EN as a height? Somebody asked. So I will explain that. How is EN as the height? Okay.
So EN is perpendicular?
EN is a perpendicular. Somebody asked about how is EN as a height. So this is a shape of an obtuse triangle. Look at this. So this, the same triangle I was drawing here. This is a triangle which I explained, the DBE. Okay. So look at this, how to draw the height. Height is outside the triangle. So it will be like this, right? So this is the height. Is it clear, Anushka? So that is En. En is the height. Okay, so this will happen there in obtuse triangle. Obtuse triangle, the perpendicular which will be outside this triangle. That is the reason what dB is the base, but En is the height. Okay, clear? So now we will divide these two. D is not the height, Muhammad Arham. Why D is not the height? Height means it should be perpendicular to the base, 90 degree. It should make the angle 90 degree to the base. That is called the height. Okay, clear? That's the reason why D is not the height. So this mic is on, I think. Okay, fine. So now we will divide these two. Area of triangle AD divided by area of triangle ADE divided by area of triangle DB. We are going to divide these two. So this comes like this, half into AD into EN, this divided by half into DB into EN. Okay, so we can cancel out EN. So this EN will go and we'll cut this half and then we'll get the remaining part AD by DB. So we wanted to get this, that is the reason what we did this process, okay? AD by DB, and this will keep equation number 1. Okay, so this is required for the further calculation. So first of all, we took the triangles with the AD and DB as the base. Now I am going to take the triangle with the AE and EC, the right hand side. AE and EC, we want to get AE by EC, okay? AE and the EC as the base. So can you tell me what are the triangles with the AE and the EC as the base? The same way. So I will read out. The first triangle is same, AD, but we will take AE as the base. And the second triangle is DEC. So look at the figure. AE as the base is AED, which is same as AD. AED or ADE. And the second triangle is DEC. We are going to do the same process for these two triangles. So now again I am going to take the triangle ADE. So area of triangle ADE is equal to, but here I will take, so look at the triangle ADE. Here I will take this AE as the base, this one AE as the base, and DM as the height. This DM is the height. So half into AE into DM. Half into AE into DM. Same way, we have to get the triangle with the EC as the base. So the triangle is DEC. So area of triangle DEC is equal to half, and the base is EC, and the height is outside the triangle, that is DM. Is it clear? The base is this one, EC. So this is the base, but the height is, being obtuse triangle, it is DM. So half into EC into DM. Now we will divide these two, you will get A by EC. I hope this part is clear. So now we are going to divide these two. So same type of process, which means we will divide area of triangle ADE upon area of triangle DEC. Area of triangle DEC. So it is half into A into dm, that divided by half into EC into dm, EC into dm. Okay, children, so we can cancel out this half and we will cut this dm and we are going to get A by EC. Okay, so this is the second one. So we got the second point. So now we want to make these two equal. We want to prove AD by DB equal to AE by EC. For that, look at these two, the left hand side, this one and this one. The numerators are same, AD, and here also in second equation also numerator is same, AD. So can we write the denominator, the two triangles are same,
Yes, sir.
DB and DEC. Yes, last year you have
Yes,
studied
sir.
chapter.
So they are on the same base and between the same parallels.
Correct. Last year you have studied that. So look at these two, DBE and DEC. If I redraw these two, this is the one, DBE, this part. And this is the one, DEC. So these two are on the same base D, right? And between the same bulk. So the denominators of equations 1 and 2. So that we will write as a special reason. Triangle DBE and triangle DEC. And triangle DEC are on the same base. So they are on the same base and between the same parallels. What is the same base, children? Same base DE or same base is same base. Okay, I will write same base DE and between the same parallels.
BC.
Yes, BC and D, right?
Yes, sir.
And between the same parallels BC and D, between the same parallels BC and D. Therefore, we can write like this, area of triangle BDE, that will be equal to what? Area of triangle DEC. Okay, so this is equal to area of triangle DEC. So this we will use in equation number 1 and 2. So equation number 1 and 2, numerators are only equal on the left side, denominators are also equal. So we can write, therefore from equations, this is like equation number 3. So from equations 1, 2 and 3 we can write, therefore from equations 1, 2 and 3, we can write like this, AD by DB is equal to A by EC. Hence, basic proportionality theorem is proved. A by EC, okay? AD by DB is equal to A by EC, hence this theorem is proved. So this is very important one. So please complete this. If there is doubts, you can clear. All of you must write and practice as well. Okay, so next is converse of BPT, basic proportional theorem, just opposite, but its statement is enough. It's main, the content, I mean, the proof is not required as per the syllabus, okay? But its statement is required. So I'm going to explain that one. All of you completed this? Okay, so now we have the converse of basic proportionality theorem. Please write the subheading. Converse of basic proportionality theorem.
Sir, is that theorem number 2?
That is like theorem number 2. No need to put theorem number 2. It is 6.2 is written in the textbook, but no need to put any number, okay? So write it as a subheading, converse of basic proportionality theorem. Right, converse of basic proportionality theorem. Converse of basic proportionality theorem. See, converse of basic proportionality theorem, that statement is like this. If we draw a triangle, the same type, if you draw a triangle, and it will be given the sides are proportional. That means a triangle ABC. So for converse of basic proportionality theorem, a triangle ABC, like this, a triangle ABC, okay, and then we have DE, but it is not given parallel. D is there, it is not given parallel. But one thing is given like AD by DB is equal to A by EC. AD by DB, which is equal to A by EC. Then we can write D will be parallel to BC. Then we will conclude that D will be parallel to BC. So that is the converse of BPT. That means the proportionality of sides will be given. Then we are going to conclude the opposite one. So what we proved here in the previous part is a given. And we can conclude the given part of the previous theorem. So please write the statement like this. If a line divides first you write the statement. If a line divides any two sides of a triangle of a triangle in the same ratio in the same ratio then the line is parallel to the third side. Then the line is parallel to the third side. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Then the line is parallel to the third side. Which means we can write like this: if in triangle ABC, if in triangle ABC, AD by DB is equal to AE by EC, then we can conclude like this: then DE will be parallel to BC. So this is the converse of basic proportionality theorem. If in triangle ABC, AD by DB is equal to AE by EC, then DE will be parallel to BC. This is the converse of basic proportionality theorem. Please complete this one. So we have studied a basic proportional theorem and its proof, but this converse theorem, only the statement and application sums are there based on this one, the converse theorem. Okay, so please write this one, the converse of Bpt. So all of you understood this concept. Here the given part was AD by this one, DB, that is equal to A by EC. Then we have to conclude that D is parallel to BC. In the previous theorem, D is parallel to BC was given, and we were concluding AD by DB equal to AE by EC. Okay, so hope this is fine for all of you. Okay, so we'll do a question based on this concept from exercise 6.2. Exercise 6.2, question number 1. In figure, D is parallel to BC. D is parallel to BC. Find EC. In figure, D is parallel to BC. Find EC. Okay, so please draw this diagram ABC, and then DE. It is parallel to BC. Means this is 1.5 centimeter it is given.
Sir, AD by DB equals AE by EC.
Correct. And this one is 3 centimeters. And this is 1 centimeter. So please try to find out and put the answer in the chat box if you can get. So we'll use the basic proportionality theorem. It is given D is parallel to BC. Okay, Jeevan got the answer, Gogul got the answer, others also can try this. Ram Prakash, correct answer. Raga got the answer. Okay, Binu correct answer, Rebecca, Muhammad Arham, all got correct answers. Okay, it's very easy concept. We can write AD by DB by basic proportionality theorem. So using basic proportionality theorem, we can write AD by DB is equal to AE by EC. Then we just substitute 1.5 by 3 is equal to 1 by EC, and from there you will find EC. So 1.5 into EC is equal to 3 into 1, that is EC is equal to 3 by 1.5, which means 2. 2 centimeters is answer. 2 centimeters is the answer. So a homework question of the same type. In figure, D is parallel to BC.
So that is also the same way.
Same way, same.
Okay.
Find AD. Find AD. Find AD. This is a triangle ABC.
Sir, could you scroll a bit up?
Okay. Is it enough?
Yes.
Okay, please complete.
What are the values in the homework question?
Sorry?
So what are the values of the line segments in the question? The
Okay,
homework
wait.
question.
Because somebody asked in between to scroll up. I could not write. Okay, so now I am writing DE. Then 7.2 centimeter, this one. DB 7.2. And this is like 1.8 centimeter, and this is 5.4 centimeter. Okay. So here D is parallel to BC. So this is a homework question. So all of you must practice well. Okay. Everybody have to practice well.